Well, hello, and welcome to Doc Onco's Physics. Keith Onco here. Today what we're going to be taking a look at is solving a problem in kinematics in one dimension, primarily in the x direction. This is the beginning of a series of problem-solving sessions where I'm going to be solving kinematics problems either in the x direction or the y direction. You'll find in the descriptions precisely what the problem actually addresses. In this first problem, what we're going to take a look at is, let me scroll down here a little bit, is we want to take a look at a word problem and see if we can't solve that using the kinematics equations that were introduced in the lessons. A couple of the things that I will have available in each one of the problems is I'll always have the equations on the upper right hand side, so it's always convenient to be able to have those equations so you can take a look at them. And also I'm going to have a data table. As I've mentioned before, physics problems can get very complicated, all right? And so we don't need our virus protection updated, so we're not going to do that. Okay. Physics problems can get complicated. There's a lot of information, there's a lot of data. If you don't have a good accounting of it, if you don't keep it organized, it can become very difficult. Okay? And so I highly recommend using something like a data table over here, and this will even get more important when we get into kinematics in two dimensions, which is projectile motion. So first I have my set of equations up here. These are my tools that I'm going to use in order to solve these problems. So it says that a car with an initial velocity of 4 meters per second is traveling on a straight road. So it's going in a straight path. The car then accelerates up to 24 meters per second in a time of 5 seconds. So let's take a look at the numbers that we have and see if we can figure out what to do with those. So the first one that we have is the 4 meters per second. So what is that? It says that initial velocity of 4 meters per second. So right away I can say that Vix is going to be 4 meters per second. And I'm going to fill that in my table. All right, that's the initial velocity in the x direction. Then it says the car accelerates up to 24 meters per second. Well, is this acceleration or is this velocity? Well, it accelerates up to 24 meters per second. If you're not sure about something in a word problem, take a look at the units. Okay? The units for velocity are meters per second, miles per hour, but it's some displacement per time period. Okay? And so this is going to be our final velocity, the 24 meters per second. So I'm going to put this in the final velocity box here. So we have Vix, we have Vfx, and it says it does it in a time period of 5 seconds. So that would be t, that would be 5 seconds down here. Okay, so what is the problem looking for? Well, it's looking for the acceleration of the car, so A. We don't need a Java update. So it's looking for A. And then later on, it's looking for how far did the car travel during that 5 second period. Okay, so let's find acceleration first. Well, acceleration, if we look up at our equation box up here, is given by the change in velocity divided by the time it took to make that change. Okay, we also have acceleration in this equation over here, v final equals v initial plus a times t, and believe it or not, the second equation here is the same as the first equation, it's just rearranged, okay? Because change in velocity is just v final minus v initial, so it's the same as the second equation. But let's use the top one. So acceleration is v final minus v initial divided by the time it took to make that change. And so v final in this case is 24 meters per second. V initial is 4 meters per second. And the time it took to make the change was a total of 5 seconds. And so we get as 24 minus 4 is 20, meters per second divided by 5 seconds is 4 meters per second, or that's the same as 4 meters per second squared. Okay, so that's our acceleration. So I can now plug that into my box of things that I know. And every time I find out a new piece of information, I'll always add that to my table, right? Because it's a nice place to keep all the information. Part B says, how far did the car travel during the 5-second period? Well, we're traveling on a straight road, okay? So how far in this case would be displacement, okay? Displacement is the change in x, which is the same as x final minus x initial, okay? So let's say that our car, all right, when it just is moving at 4 meters per second, at just this time right here, this is when it starts to accelerate. So this is the 5 seconds period from here to here. Well, remember that I can choose my coordinate system to be anything that I want. So I'm going to choose my coordinate system where my car initially, just as at time equals 0, is at x equals 0 position. Okay, so my initial value, my x initial value, is 0. And I will almost always choose to do that unless the problem states otherwise, unless the problem says that my initial starting position is, say, at x equals 5 or 10 or 50 or something like that. I can choose x initial equals 0 anytime, and that's perfectly valid. So I'm going to fill in a 0 up here for my x initial position. So if that's the case, then my delta x, my total displacement, simply equals x final, my final position. So it makes the math a little bit easier. So what I'm looking for, I'm looking for the change in x, or x final. Well, which equation is going to help me with that? Well, the first two really aren't going to help me with that. The third one could, if I knew the time, all right? Do we have the time? Well, yes, we do, right? So let's look at the variables. We're looking for x final, all right? We know x initial because we set that to be 0. We know the initial velocity is 4. We know the time is 5, the acceleration is 4, and again the time is 5. So we have everything we need right there. So we could find the x final using that equation. Now, the fourth equation also has the change in x, right? The displacement, x final minus x initial. Let's see if we could potentially use that equation. Well, do we know A? Yeah, we do. Do we know the initial velocity? Yes. Do we know v final? Yes. So we could use either the third or the fourth equation, and either one would suffice. But let's use the third one, since that seems to be more direct in finding x final. So x final will equal x initial, which is 0, plus v0 times t. Well, v0 is v initial, so that's going to be 4 meters per second, times t, which is 5 seconds, plus a half, 0.5, times a, which is 4 meters per second squared, times t squared, times 5 seconds squared. Okay, I'm just running out of room there. All right, so when we do the math, 4 times 5 over here is 20 meters. All right, seconds cancel out. Plus 0.5 times 4 is 2. 2 times 25 is 50. So we get 50 meters over here. And so what is x final? X final turns out to be 20 meters plus 50 meters. So we go 70 meters. We travel 70 meters during that 5-second time period. Okay, so this is how we solve a basically simple problem that's one-dimensional kinematics, knowing certain information. And I hope that helps. If you need to watch more, look up the different